And myself Rekha, Assistant Professor, Department of Mathematics. So today I am going to explain the topic test of hypothesis in the small sample test t-test problems and its solution. So this comes under the course Discrete Mathematics and Probability and Hypothesis Testing. So next I am going to explain one problem. And manufacturing company claims that an average lifetime of an LED bulbs is 5,000. A sample of 10 bulbs given average lifetime of 4,800 hours with a sample standard deviation of 300 hours. We have to apply the one sample test. So normally t-test is nothing but an n less than 30 means we have to apply the t-test. So here the bulbs is values minimum, so we can apply the t-test. Okay, so n is equal to 10, so that is less than 30. So the formula for the t-test is t equal to x minus mu by s by root 10. S is nothing but here mean, and mu is nothing but population mean, and s is nothing but standard deviation, and n is nothing but a sample. So 4,800 minus 5,000. So if you simplify s by root 10, you will get 94.87. So you will get 80 equal to 2.11. So this is computation. So we can find the t-test. And using this t-test, we have to find the degrees of freedom. So degrees of freedom is nothing but df equal to n minus 1. N is nothing but 10. So 10 minus 1 is nothing but 9. And we can compute the standard error. So standard error is nothing but s by root 10. So that already we have calculated in the above 94.87 you got from the value by calculating s by root 7, that is 300 by root 10. So it is 94.87. Okay. So next we will see the next problem. So another problem is nothing but based on the t-test. We can move on to the next problem. So this is also an 6-mark question. In a data science project analyzing employee performance, a sample of 16 analysts from one firm yield of average daily output of 42 reports. And here the standard deviation is given as 3.8 reports. The industrial standard mean output is 40 reports per day, and we have to conduct the t-test with 1% significant level. Okay, so here also we have to, for all the problem, we have to set the two hypotheses. One is null hypothesis, another one is alternate hypothesis. Null hypothesis is nothing but h naught mu equal to 40, h1 mu greater than equal to 40. So t-test is nothing but t equal to x minus mu by s by root 10. So here the sample mean is x equal to 42 and the standard deviation is 3.8, whereas the mean is mu equal to 40 and alpha the significant is 0.01. Okay, so next we can see the next problem. Same problem, we have to calculate the standard error 3.8 by root 16, that is 3.8 by 4, you will get 0.95. And we have to complete the t-test, t equal to 42 minus 40 by 0.97. So we will get t equal to 2 by 0.95. Here critical value is t equal to 2.11. Okay, so therefore the critical value is 2.11 means here the degree of freedom is, we can calculate it as n minus 1, that is 15. So 15, the degree of freedom is 15, so the critical value is 2.60 here the critical value is less than 2.11, so we can accept the null hypothesis and we can reject the alternate hypothesis. Okay, so alpha 1% means there is no insufficient evidence to conclude the firm analyst exceeds the industry standard of 40 reports per day. So finally we can conclude that the firm analyst does not exceed the standard employee productivity analysis. So for all the problem we have to calculate the critical value and as well as the test of hypothesis in that. Okay, so next another problem is a market team test a new campaign by surveying 20 customers, finding an average satisfaction scores of 7.8 and standard deviation 1.8. The historical population means 7.0. Here you have to find the alpha and the 5%, and you have to test the campaign whether it is a campaign is improved satisfaction or not. We have to test the two hypotheses. One is h naught Another one is h1. So here also the mean n equal to 20, x equal to 7.8, s equal to 1.10, mu equal to 7.0. Alpha, if you take the 5% level, means we can conclude it as an 0.05. So this problem can be calculated like this, that is t equal to x minus mu by s by root n, and s by root n is nothing but 1.2 by root 20. Root 20 value is 4.472, will get 0.268. So calculating this t-test, we will get x minus mu by s by root n, 7.8 minus 7.0, 0.26, so we will get 2.99. But the degree of freedom is 19, so we have to acquire the table value of s nothing but 0.57 in the 19th degree. That critical value is 1.729. We have to compare this critical value with that t-test, that is 2.99, that should be greater than 1.729. So we reject the h0 and we accept the alternate hypothesis, and alpha 5% level to conclude the campaign as an significantly improved customer satisfaction. So I think these problems you can understand easily by comparing all the t-test and as well as, and remaining problems also I have given, and based on the same problem, same category, you can solve the given problem with the various parameters. So thank you for you solving that is watching this sample test and t-test problem.